Hi, I'm Randall Heyman, a mathematics academic. I've turned over my YouTube channel exclusively to make videos to help students impacted by the coronavirus outbreak. So if you're a lecturer or a tutor, a high school or a primary school teacher, a parent, a grandparent, or in fact a student, and you'd like me to make a video for you or your students, use the comment section below the video, or you can drop me an email. You can see the address above. Okay, we've been clocking through a whole lot of stuff about abstract algebra. I previously went through a proof that if D here is an integral domain, then dx is also an integral domain. And someone's asked me to do a little bit more detail on proving one aspect of that, which I skipped over a little bit lightly in the previous video, and that is to show that if D is an integral domain, then dx has a multiplicative unit, because that's one of the important, in fact, essential parts of showing that dx is an integral domain. So I suppose let's do that. How are we going to start this? Well, since D is an integral domain, and here remember we're just, in the back of our mind, we're just thinking that D is actually the set of integers. That's the classic integral domain. So since D is an integral domain, we have, we know that, what do we know about integral domains? It has a multiplicative unit So let's call it 1. So what does it mean to have a multiplicative unit? Well, it means that 1 times, say, D equals D times 1 equals D, and this is for all D that are elements of the integral domain. This is basically the definition of a multiplicative unit. You take this multiplicative unit, you multiply it by any element in the integral domain, D, and that equals D times the multiplicative unit. So in other words, it doesn't matter which order you do it, and in both cases it actually equals the number D itself. That's the essence of what a multiplicative unit is. Okay, so now let's link that into dx. How are we going to do that? Take an arbitrary element of dx. So remember, dx is just the set of all polynomials that have x as the variable, where the coefficients are only elements of D. So if take an arbitrary element of dx, so we'll call it, I suppose I could call it d0 plus d1x plus d1x squared plus d subscript m x to the m, where m is an element. Actually, we want m to be, that's the degree of the polynomial, we want to be a positive integer. And di, all these di's, all these d's are elements of the integral domain. I'll just put for all I, that's enough. Okay, so then, well, let's do 1 times d. 1 times d, well, the rule with, not 1 times d, 1 times the polynomial. So 1 times d naught plus d1x plus dot 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 plus dm x dm. Well, this is a polynomial. It's a very simple polynomial. It's just a constant. Times this. Well, the way polynomial multiplication works, remember, all of these integral domains have two operations, addition and multiplication. And the way multiplication works for polynomials is that in this case, we're just going to multiply that by that plus 1 times d1x plus dot 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 plus 1 times dm. And since 1 d0 dot dot dot, all of these are elements of the integral domain, then 1 times any of these is just equal to that. That's what we just had up here when we discussed an integral domain. Remember, at this point now, this here, this 1 and this d0, well, when I say this has got nothing to do with polynomials anymore. This is just two elements of the integral domain, say of the integers. 1 times any of them is just equal to the same thing for all I. Since then one of you, so 1 times, so what I'm saying is that 1 times d1x plus dm x to the m is just, well, this one here is just equal to d0. This one here is just equal to d1 times x. So we're just using the property of the integral domain D. And next, we can do it the other way around, of course. d0 plus d1x plus dm xm times 1 equals, this time it's d0 times 1 plus d1 times 1x, and that will go all the way up to dm x to the m. And again, well, so similarly, whoops, let me just lift this up. It's going to get a little bit hard to write. Okay, let's do this. di times 1 equals di for, since 1 d0 d1 etc dm elements of the integral domain. So what we're saying is that d0 plus d1 x plus dm x to the m times 1 is just equal to, well, I'll take this bit here, that's just d0 from what I just wrote in the last line by that logic. By the logic of the previous line, this is just d1x, and same for this. So I'll just put a summary here, although I could just put that completes the proof. But here, therefore, we have shown that 1 times, let's call it dx equals dx times, dx times, well, actually, let's, yeah, that'll do, dx times 1 equals dx for all of these polynomials that are elements of the integral domain dx. Therefore, thus, dx has a multiplicative unit. So that, I didn't write the proof up the top, but that's basically the idea of the proof in some detail. So I hope that's helped out the person who asked that question. I was on radio, I got on radio last night, and I was just talking about the fact that I've got this YouTube channel and I've devoted it to helping students around the world. Mentioned a couple of the classes in California that I've helped. So that might lead to a few more inquiries domestically, but if you know, feel free to pass the word around about what I'm doing, because I'm happy to help anyone in the world who's impacted by the virus in terms of their learning about maths. And also, if you just want to chat about any aspect of maths, if you've got downtime and you just feel like talking about some ideas in maths, by all means, leave a comment below the video or send me an email.